Okay, this section is 9.2, arithmetic sequences. And this is a topic that you saw in Algebra 2, and you saw it almost exactly the way that you're going to see it here. And that's why I'm going to try to do this in a slightly different way, and we'll just see how this works. An arithmetic sequence is a sequence that you get the next term by adding the same number every time. So if you look at a sequence like this, 7, 11, 15, 19, you notice that we keep adding 4 to get the next term. So I could tell you that the fifth term, the one that comes after 19, should be 19 plus 4, 23. Right? So an arithmetic sequence, if you subtract successive terms, in this case, you get 4 every time. So we would say that the common difference, which we call d, lowercase d, is 4. So we could write a recursive formula for the nth term of an arithmetic sequence would be the term that came before it, which is if we're finding the nth term, then it would be the n minus 1 term plus the common difference. And notice in the formula that this is the formula for the nth term in the sequence, right? This is the a sub n. This is an explicit formula, actually. That first it looks linear, and like mx plus b. That's how you know you're dealing with an arithmetic sequence. And also, because we've already identified the common difference of d, which is 4 in this case, notice where that 4 shows up in this formula, right? It's the coefficient of n. So that when we increment n by 1, it means you get another multiple of 4. You add 4 one more time. Okay, the next sequence, 2, negative 3, negative 8, negative 13. Again, if we do the subtraction, you always have to do the second term minus the first term, the third term minus the second term. Make sure you do it in the right order so you get the correct sign. In this case, it's negative 5, negative 5, negative 5. Right? So our common difference is negative 5. Right? I would get the next term by adding negative 5, it would be negative 18. And I can see in this formula for the nth term in the sequence, again, it looks kind of linear, n to the first power, and our common difference is showing up as the coefficient of n.